Welcome to our today's session. Today we look at the rules of differentiation. I begin by noting that differentiation is basically the rate of change of one variable compared to another. So when I talk about dy dx, meaning the rate of change of y compared to x at any given point. Suppose your income was 50,000 10 months ago. Currently, it is 80. So the rate of change of your income, the rate of increase of your income is 80,000 minus 50,000 divided by the 10 months. So it gives us 3,000 per month. So when I talk about differentiation, differentiation would depend on the kind of function that you're dealing with. And that gives us the rules of differentiation, each applied on the function that is appropriate. So I begin by the derivative of a constant, and that is what I want to look at first. Rule number one, derivative of a constant. I begin by noting that throughout, the derivative of a constant is always zero. The derivative of a constant is always zero. The question is why? If you remember very well, is that when you are given a constant function y is equals to c, looks like that, where this is x and this is y. So when I talk about the rate of change of y compared to x, the rate of change of y is zero. If x was here, x1, and I have x2 here, the change in y is zero, and the change in x is delta x. So that change in y, if you look at it this way, the change in y is zero over the change in x. So the change in x, irrespective of what it will be here, this will always give us zero. So if I have an example of y is equals to 8, the derivative of 8 is always zero, because this line is y into x, and this is the line y is equals to 8. Y does not change. So therefore, I want to note the derivative of a constant is always constant, is always zero. Power rule for positive integers. When you are differentiating positive integers, the function will look like what I have given you there. The function will look like this. So to differentiate this function, the rule is simple. Simply to get the dy dx, simply get the power of x, bring it in front there. And then that same power, reduce it by 1. So if I have an example like this one, if I have an example like what I have given you there, that is y is equals to x raised to 5, then simple. This y will be, my 5 comes in front, so I get 5 there. Then I say 5 minus 1. So I will have x raised to 5 minus 1, which is 4. And that is what I have given you there. My 5, which is here, comes there. And my 5 is subtracted 1 to give me that. Meaning that if I have y is equals to, let's say, x raised to 3, then my dy dx will simply be, I'll bring 3 in front, then x, I subtract the power by 1, I get 2. I have another one there, which can still show you that if I have y is equals to 2 x power 3. It means that dy dx is equals to 2 times 3 x raised to 2. I reduce it by 2. So this gives me the product is 6, then x times 2. So this power of mine multiplies that number there, and I reduce it by 1. Sum rule. Now, sum rule, basically when you are given, we are saying sum rule, we are assuming that we have two numbers, two variables, two functions, u and v, which are differentiable functions of x. So the sum, when you look at the sum, it's like differentiating each separately. So when you look at this, this is a separate function from this. So I apply the same method, but I differentiate each alone. So to differentiate this, I look at the derivative of this alone, and then the derivative of the other one alone. So how then do I get it? The derivative of 12x, it means the power of x here is 1. So that power is what I move in front. So I write 12. So the power of x is 1. So I remain with x, 1 minus 1, plus the power of x here, I write 3, then times, I bring 2 in front, I bring this 2 in front there. So I get to x, then 2 minus 1. So the answer becomes 12x raised to 0 plus 6x. So any number raised to 0 is 1. So I get 12 plus 6x, which I've given you here. So at your free time, you can show me that actually this is equal to 1. Thank you very much. That makes the end of our class today.